This is a key to the free response half of the forces test from November 9th and 10th. It was important to follow the directions. They tell you what I'm grading for, and it's of course what the AP readers will be grading for. So you had a helicopter holding two packages. There was more than one version of this. The problems differed by how much mass each package had and by the acceleration of the helicopter. So you begin to work with the system as a whole to find tension 1 easily. So that's tension 1 right there. And that's the rope that's holding all of the mass. It's the upper rope. And therefore, I'm going to combine the two masses. 30 plus 30 makes 60 on one version, or 35 plus 35 makes 70 on another version. And that's the one I have here. And I have a net force equation that's useful here. Notice it says specific net force equations. People who started off writing MA equals T missed the boat. You need to add all the forces. And the way you do that is by using your free body diagram. So many of you have gotten very good at that by now, which is great. So net force, sigma F, or MA equals tension up and weight down. So you don't want to just write sigma F equals MA. It's just not useful enough to solve a problem. It's quite true, but you need to be more specific. So here I have the combined masses, the two masses together, times the acceleration that I'm given. There's mg, again using the combined masses, and I have a solution to the first one. Any single object produces a free body diagram. That free body diagram produces an equation. The net force equation has to have a mass in it that matches the mass in the diagram. On the second box, which is T2, this is the lower one, that rope is lifting only the lower mass. So I need a second free body diagram. This one's worth 2 points, or 2 parts I should say, and this one's worth 2 parts. These are 2 parts out of 50, so it's actually 4 points out of 100. So the sum of all forces on the lower box is tension 2 minus the weight of just the lower box. I move down here to have a little more room, put in the numbers, and I can find the tension in rope number 2. On another version of the test, the one with 30 kilogram boxes, you can see the answers here. On both versions, we were looking for the following things: a free body diagram, a second free body diagram, a net force equation, and a second net force equation. Tension 1's correct answer, tension 2 correct answer, and there was a point for substitutions. So that's 2, 4, 6, 8, 10, 12 right there. Look at how much of your credit is going into free body diagrams and net force statements. You can expect that to continue all year and into May also on the exam. This, by the way, I should say, is the a couple of forms that I'm calling truck, because the last problem in this test has a truck on it. So here we have an Atwood problem, and there's a bigger mass and a smaller mass, so you can use B and S, or you could have called these 12 and 9, or on the other version of the test, you could have called the two masses 13 and 11, but you just want numbers, remember, if you're using them as names. So it's important to have a single system of signs. So remember the Atwood convention. Anything that helps the big one fall down is positive. Anything that fights it is negative. So therefore, I put the signs on tension, just as you'd learned in your notes, and I write a net force equation for the big object. Negative tension plus the positive weight, pulling it down. Substitute in mass times acceleration, even though I don't know acceleration, and now I have negative tension plus mg. And at this point, I have an equation with two unknowns. Tension is unknown, and so is acceleration. I need another equation. So now I write a second net force equation. This one's worth 2 points. That one's worth 2 points. 2 parts, I should say, because it's really 4 points. That one's 2, and that one's 2. So once again, 8 parts here are net force statements and free body diagrams, as promised. So here we have 9 times the unknown acceleration, because this one had a mass of 9 kilograms. And I'm solving for tension here, and I have an equation with the same 2 unknowns. So I chose to set my 2 tensions equal to each other. You can see the black and the blue here, and I solve for acceleration. If you do that on the other form of this truck test, you get a similar approach, and you get that answer. Now I can use A and solve either tension equation, either this one or that one, or I can do both if I want to check my work. On this particular one, it's 101 newtons of tension, because I just take this 1.4 and I substitute it in right there to solve. Or I take the 1.4 and I substitute it right there and I solve, and I should get the same answer, and I do. It's 101 newtons on that one. On another version, it was 117 newtons. That's the one with the 13 and 11 kilogram masses. Points again, free body diagram, net force statement, net force statement. You have to have two. You can't have objects tied together and have that count as a free body diagram. It counts as nothing, okay? It is drawn in the problem for you, but you have to be the one to free them and separate them so you can study forces. All right, moving to the third problem. This was pushing an object across the floor, so there was a downward component to the push. Important also to recognize you were given constant velocity, which is really nice because that lets you know acceleration in every direction is 0. And their first job was to find the normal force. Well, we recognize that the net force in the y direction is 0, and we add up our positive forces. So I have an upward, I shouldn't say positive forces, we add up our vertical forces. I have an upward normal force, that's going to be a positive. I have a downward weight, that's going to be a negative. Py is also downward, that's going to be a negative. You need to draw all force vectors starting at the mass. That's the way to get them right. That lets you see that this is indeed negative and going down. So when your signs are right, you can go ahead and rearrange and solve for the normal. The y component right here is going to be found opposite the angle that we know. So that's the sine, p sine theta, is going to help us balance these two downs and that one up. And here I get a normal force of 194 newtons. On a different version of that same question, the push was just different. It was 71 instead of 91, and the normal force here is 183. Now that I have the normal force, I need to find the coefficient of friction. So I move down here for some extra room. Again, I'm happy that I have no acceleration because I have constant velocity. I get a 0 there for mass times acceleration, making things easy. I can set the frictional force and the x component of the push equal to each other. So this x component I've drawn to the right, and that force of friction I've drawn to the left. And we are opposing them and solving for mu, the coefficient of friction. The x is adjacent to the angle that I know, so the cosine comes into play here. And here I have to use my unrounded version of the normal force I calculated. So this is my 194 number, unrounded, and that gives me the coefficient of friction. On the other version, the one that had a 71 Newton force, I again use the normal force I calculated, and right there I've got 0.326. You cannot say in a situation like this that the normal is equal and opposite to the weight. You have three vertical forces or force components. You have something acting at an angle. Those things are going to tell you the normal is not mg. So how did the points go here? Well, 2 parts or for free body diagram, 2 more parts of credit for summing the forces in the y direction, for a net force statement in the x direction, for the correct answer for the normal force, correct answer for the coefficient of friction, and then 1 part or point for using the sine appropriately, using the cosine in the x direction, and knowing the friction equation and being able to make it work. The last problem was the truck problem. So just to be fair, let's look at the other version this time. So the driver hits the brakes. A, find the magnitude of the average acceleration of the truck. Everybody had a kinematics question on here, so something to review, in other words, from our very first unit of the year. So you could use the definition of acceleration equation quite easily to get that acceleration. You've got 1 point for the algebraic formula, and again, that's really 1 part out of 50, so it turns into 2 points on a 100-point scale. 1 point for showing substitutions, 2 for getting the correct answer. It said magnitude, so you did not have to have the negative sign. You could use any motion equation that works. So, for example, in this one, I could have used the stopping distance for the truck, the VF squared equation, and I would get the same result. If you had the other version, the difference was just that there was a different stopping distance and a different length of time required for it to stop. Both of those numbers will generate the same acceleration, by the way. So the magnitude here is 4.15. The actual acceleration is negative because it's braking, and it's drawn moving to the right. On a box that looks like this, a square, we have normal straight up, weight straight down. Those two things are equal and opposite to each other. We're on a horizontal surface, and friction is the only horizontal force. Isaac Newton's first law of motion says you don't need any forward force to explain this, okay? It's just moving forward on the basis of the fact that it's always been moving forward. We can think of it that way anyway. So now, as I'm looking for the coefficient of friction, I'm going to sum all the forces in the x direction. It's that very short list, okay? I'm not starting off sigma F equals ma. but that's then the next line, right? There's my sigma F equals ma. It's like a vertical stack. So mass times acceleration would have been a find start 2 equals mu times the normal force, the equation for friction. So you have 2 points for a good net force equation, 2 points or parts for a good understanding of friction and how to substitute in to get friction. And then when you go ahead and calculate, 2 more for getting the correct answer. That's the coefficient of friction here, and there's the coefficient of friction there. So that concludes the grading and the key for the truck test. Make sure you go over this, and if you have any questions, go to your notes. And if you find that you still have questions, please come to tutoring, come to office hours. You can expect to see all these things again on the AP exam in May, and also on our final exams in December and in May or June.